morning, students. Welcome to today's online science class. Standard 7, Unit number 2, Electricity in Term 2. In this session, we are going to see about potential difference and then electrical conductivity, resistivity, and this and all the topics we are going to cover in this session. So first, potential difference. So the electrical energy must need some energy to push them along a circuit. For example, do you know the water? So the water always flows from higher to lower ground. Similarly, an electric charge always flows from the higher potential to the lower potential. An electric current can flow only when there is a potential difference. It is denoted by the letter V, or it is represented by PD. It is in a capital letter. Next, unit of potential difference. So what is the unit of potential difference? The SI unit of potential difference is volt. Did you ever notice that precautionary board while crossing the railway track and the electrical transformer? What is the word high voltage denotes? Look at the symbol, students. The term mentioned in the board, volt, is the measurement for the electrical potential difference. The SI unit of potential difference is volt and its symbol is capital V. The potential difference between 2 points is measured by the device. It is called as voltmeter. The potential difference between any 2 points in a circuit is the amount of energy need to move from one unit of electric charge from other point. It is the amount of energy which helps to move from one point to the another point. This is called as the potential difference. So next, electric current flow from the higher potential level to the lower potential level is just like a water flow. Okay, so next we are going to see about electrical conductivity and resistivity. So first, resistance. So the resistance is represented by the letter R, and then electrical conductivity is represented by the symbol sigma, and electrical resistivity is represented by the symbol rho. Okay, what is the meaning of resistance? Resistance is the opposition to the flow of charge. So though it is the opposition, it opposes the flow of a charge. An electrical component resists or hinders the flow of electrical charges when it is connected in a circuit. In a circuit component, the resistance to the flow of charge is similar to how a narrow channel resists the flow of water. The higher the resistance is a component, the higher the potential difference needed to move electrical charge through the component. We express resistance as a ratio. Resistance of a component is the ratio of potential difference across to the current flow through it. That is, R is equal to V divided by I. The SI unit of resistance is ohm. And next, electrical conductivity. So the electrical conductivity is the measure of a material ability to conduct an electrical current. It is commonly represented by the Greek letter sigma. See the picture. And then the SI unit of electrical conductivity is Siemens divided by meter. That is S divided by M. Okay. So next, electrical resistivity. It is represented by the symbol rho. Okay. See the symbol, students. So the electrical resistivity is a fundamental property of a material. It is a fundamental property of a material. That quantity is how strongly that material opposes the flow of electric charge. Okay. So the SI unit of electrical conductivity is ohm meter. So the electrical conductivity is the measure of the ability of the material to conduct the electrical current. Okay, ability of the material to conduct the electrical current. So the electrical resistivity is the fundamental property of the material that opposes the electrical charge. Next, now we are going to compare the electrical current with the water flow. Okay, analogy of electrical current with water flow. So an electrical current is a flow of electrons. We already know that. So current is the flow of electron through the conductor. That is the wire, like copper wire. We cannot see the electrons. However, we can imagine the flow of electrical current in a wire like the flow of water in a pipe. Okay. Let us see the analogy of flow of electrical current with the water flow. Now we are going to compare the electrical current with the water. Flow of water. Water flowing through pipes is pretty good mechanical system. That is a lot like an electrical circuit. This mechanical system consists of pump pushing water through a closed pipe. Imagine that the electrical current is similar to the flow of watering through the pipe. The following parts of the two systems are related. Now we are going to relate the electrical circuit part and then water flow systems. Okay, so the pipe is like wire. Okay, now first the pipe is compared to the wire in the electrical circuit, and the pump is like the battery. So pump, that is equal to the battery. The pressure generated by the pump drives water through the pipe. The pressure is like the voltage generated by the battery, which drives electrons through the electrical circuit. Okay, suppose there are some dust and rust that block up the pipe and slow the flow of water, creating a pressure difference from one end to the another end of the pipe. So if there is some rust in that pipe, so the flow of water will be low. So there is the potential difference between the one end to the another end. In a similar way, the resistance in the electrical circuit resists the flow of electrons. So we already know that the resistance which opposes the flow of charges. Okay, so the resists the flow of electrons and creates the voltage drop from one end to the another end. The energy loss is shown in the form of heat across the resistor. More water current, that means the flow of electric charges in the current is more. Less water current means the flow of electrons in the wire is very less. Okay, let's recap the today's session important points. So the potential difference, it is denoted by the letter capital V. The SI unit of potential difference is volt. And then electrical conductivity, the resistance relation is R is equal to V by I. The SI unit of resistance is ohm. And then electrical conductivity is represented by the symbol sigma. And then electrical resistivity is represented by the symbol rho. The SI unit of electrical resistivity is ohm meter. Okay. And then lastly, we compare the electrical current with the water flow. So that's all. Thank you all.